When is ready? Are you ready?
Yeah.
Oh, okay, go.
Good morning, ladies and gentlemen. We're Group 4. We call ourselves True Perspective. My name is Ben Roberts. This is Daniel Sloan, Joshua Fearball over here, Michael McGregor in the back, and Zach Murray. We're here to tell you all about our wonderful product. So, just so you guys know, they say, tell them once, tell them twice, tell them time. So, our outline, we've got head tracking. We're going to talk about the status quo, which is current status, our solution, features that we have, our application we're showing off with, face tracking in general, how we get it working, our other possible use cases, and then of course we'll ask any questions. You'll ask us any questions that you have.
So we want to talk about just the background behind head tracking. We want to make a project that relates to head tracking that's, well, it's fun and easy to use. That was our goal for this semester. We want to make something that we can draw on lots of developer interest with. We want to make something that is easily supported by developers, or for developers, so that developers can create with our API many different applications that have to do with head tracking, because no such platform exists at this point. There's no platform in existence today that a developer can take and quickly create a project with.
So one of the things that we started looking at very early on in the project is how we can bridge the gap between computer vision and computer graphics. Face tracking involves both, and we really wanted to bridge that gap. When we started doing our initial research phase, we came up with two graphics and two libraries that we ran into two different libraries. And each one of them had different pros and cons that both help us, but neither do everything that we wanted to do. So all of the features of OpenCV don't really match that well with OpenGL. And OpenCV, for example, has no hardware acceleration, but it does have camera support. So what we wanted to do is take both libraries and make a new library that integrates both of them. And so what we came up is the True Perspective platform. Go ahead. And our solution unifies both computer vision and graphics. And we really want to aim to simplify the application development process by providing an interface to both that hides the implementation details thereof. Our goal is to implement this system so that it's solid and runs on many different platforms. And we also want to provide solid, detailed documentation so that it's easy to take our platform and run with it. Also, with the well-documented bullet point there, it's easy to learn, and we want to also provide some tutorials with our product that we'll submit and make it easy to get started with it.
All right, some of the features for our True Perspective product. Of course, talk about head tracking. Our product will have full object tracking and detection. We will have friendly user interfaces, elements that will allow the user to do cool and different things with display. We have a human-computer interaction device support. So basically anything with a webcam and with what we're showing our application. Teleconferencing. This True Perspective also has multiple camera support. Again, going back to the teleconferencing aspect, and also supports a 3D graphics engine.
Now, while our core project is actually the platform, the API, and all that, that's not very impressive. So for the Capstone Expo, we're making a sample application, a use case, to show off like one possible use case of our application. We're making a telecommunications program so that it's basically client to client, and it is like teleconferencing that reacts to your point of view. It's going to show off the 3D capabilities of our API. It's going to show off one of the possible uses and make it look a little bit more flashy, make it more sellable. The way it works is we use a thing called a hard classifier. I'm not going to get into the details, but it's basically a training set that teaches the software what a face is. It finds a face and squares on it, and then we take the average color within that square and make a blob out of that. And then we track that average color, and it saves so much processing power and so much time to just track that blob. And then we just refresh, try to find a face every now and then to make sure we haven't really lost our face. And then, once we have our face and we can track it, we take a vector from the middle of the screen to the center of the face. Maybe we're playing with moving it up and down based on the eyes because your eyes aren't exactly in the center of your face. And use that to determine the user's perspective, and then move the screen and translate the screen based on that, and how big the square is, like the ratio of the square for the face to the total screen. We will zoom in and out to like simulate how close you are to the person you're talking to.
This is a screenshot of one of the early prototypes of the software. You've seen this before. As you can see, there's the box drawn around the face, so it's successfully tracking. And of course, like you said, we'll have a situation such that when it detects your face over here, the image literally moves to accommodate, so that it's like you're looking through a window. But like you said, this is one use case. That's teleconferencing. It's very useful. It's very interesting, but it's by no means the only use for this API. There are uses in security and in face tracking. If you could use a hard classifier for a particular person's face, you could use it for identification of particular people, such as top 10 most wanted list. And cameras are everywhere these days, so that'd be useful. Video games, everybody likes interactive video games. Imagine a first-person shooter that actually responds to the position of your head, so that when you're aiming your gun or whatever, it's actually like you're in the game. Television, there's many uses there. Movies, again, just more interaction between where your location is and what's going on the screen. Various user interfaces, again, that kind of goes into video gaming and other situations where the gestures could actually be picked up with different hard classifiers. And you could actually, in fact, use it for any kind of software that wants to recognize who the user is, so that instead of typing in a username or what have you, it literally recognizes you based on your face. And of course, live interfaces, which is what our example case is, which would be the teleconferencing.
And before we ask for questions, I'd like to add that it's really important to note that while the main application for the software and the more built-in application is for facial tracking, really you can do anything with the hard classifiers. You can have hand gestures, and to make a hard classifier, all it is have maybe 1,000 positive images of just what you want with an alpha background, then throw in a couple hundred negatives that might look kind of like a positive, so you know what not to look for. You could, I've seen online where people do stuff with hands, where this could be a gesture that controls a computer, like maybe this is play or something. Or you could track, say, a ball, or a teacup. There's so much you can do with it if you just have the creativity, and that's why there needs to be a platform for this, because there's no easy way to do it. You have to deal with this horribly documented software, you have to throw things together, and we're just saving a step. We're being the middleman. Any questions?
Do you see any application for this platform in creating applications to help people who are wheelchair bound, where they can only move their head, point to some object? Maybe you want somebody to bring you the teacup or whatever. So you cannot speak and you cannot move, but we are able to gesture by moving your head. Is there a possibility for an application like that?
Off the top of my head, you could put on the wheelchair, maybe somebody's quadriplegic and can just move their neck up. You could probably put a camera centered on their head, and they can look left to turn, pivot their wheelchair left to right. They can control like that, look down a little bit to move forward.
Or you could simply have a scroll bar of things that you'd like and a list, so they move their head and it moves along the scroll bar, and then they make a different gesture and selects it. Really, that's kind of the good thing about this, is that it's not any one particular project. Anything you could imagine could be done. So that's kind of the point behind the API.
So are you leaving enough detailed documentation if another group next semester wants to say build an app for helping a disabled person or something? using your
Absolutely.
platform?
Absolutely.
It's the main purpose of this.
And in fact, we're going to deploy with our classifier cascade of faces with the application on our final project as well. So you'll be able to get ready and running with detecting genome faces out of the box.